Hello everyone. So in today's video, we will find the exact value of tan of pi over 12. So the first thing we should do is try to relate angle pi over 12 with the special angles. So the special angles are pi over 6, pi over 4 and pi over 3. So pi over 12 is half of pi over 6. So one way to evaluate tan pi over 12 is to use the double angle identity for tan. But a better option here is to use the tan angle difference identity. We know that pi over 6 in degrees is 30 degrees. So we should convert these angles to degrees to get a better sense of how we can use pi over 12 as a difference of these special angles. And pi over 4 is 45 degrees. Now pi over 12, if I have to convert it to degrees, I just have to replace pi by 180 and I get 15 degrees. So 15 can be written as a difference of 45 and 30 degrees. It can be 45 minus 30 degrees. Now it can also be written as a difference of pi over 3, which is 60 degrees, and 45 degrees. But you can use either of those two differences to get the exact value of tan pi over 12. Now since the given angle is in radians, we should show all our steps in radians. So the first step is to break down pi over 12 into a difference of pi over 4 and pi over 6. We can simplify this expression using the tan angle difference identity. So the tan angle difference identity is tan of x minus y is equal to tan x minus tan of y over 1 plus tan x tan y. Now in our expression, so x is pi over 4 and y is pi over 6. So now we can expand our expression using this identity. So we get tan of pi over 4 minus tan of pi over 6 over 1 plus tan of pi over 4 times tan of pi over 6. And now we can simplify this expression. So we have to find the values of tan pi over 4 and tan pi over 6. And for that, we'll have to use the special triangles. So the special triangles for pi over 4 and pi over 6 are, so I'll draw them on the board. So this will be the special triangle for pi over 4. So it's a right angle triangle. 1, 1 and square root of 2. And then the other special triangle for pi over 6 is this one. So this is pi over 6 and this is 1 square root of 3 and 2. Now we know that the formula for tan as per SOHCAHTOA is opposite over adjacent. Now we can rewrite our expression as, so tan pi over 4 will be opposite, so this is the opposite side. So it will be 1 over, and this is the adjacent side, so 1 over 1, which is equal to 1. So 1 minus, now tan pi over 6, so this is the opposite side, and the square root 3 is the adjacent side. So 1 over square root of 3 over 1 plus 1, tan pi over 4 is 1 times 1 over square root of 3. Now we can simplify this expression. So we can move to this side. So we get 1 minus 1 over square root 3 over 1 plus, so we do 1 times 1 over square root 3, which is also just 1 over square root of 3. Now we can simplify the expressions in the numerator and the denominator. So in the numerator, we have to find a common denominator. So the denominator of 1 is 1. So the common denominator will be square root of 3. So we'll multiply the numerator and the denominator by square root of 3. And we can do the same thing in the denominator. So we have to combine 1 and 1 over square root 3. So the common denominator is square root of 3. So the new expression becomes, so here also we have to multiply. So we get square root 3 over square root of 3 minus 1 over square root of 3 over square root of 3 over square root of 3 plus 1 over square root of 3. Now we have a common denominator, so we can combine the fractions. So in the numerator we get square root of 3 minus 1 over square root of 3 over square root of 3 plus 1 over square root of 3. Now we can simplify this expression by flipping the fraction. So we flip the bottom fraction. So we get square root of 3 minus 1 over square root of 3 times square root of 3 over square root of 3 plus 1. So we can cross reduce these square root 3's. So we get square root of 3 minus 1 over square root of 3 plus 1. Now we cannot have a radical in the denominator. So we'll have to rationalize this radical. So we do that by multiplying the numerator and the denominator by the conjugate of the denominator. So the conjugate is an expression with the same terms but with the opposite sign. We have to combine these terms in the numerator. So basically we get square root of 3 minus 1 square, because the same terms with the same sign, over, now in the denominator, in order to combine them, we can do FOIL. So we can distribute the terms. So we'll have to do this, and then we multiply 1 by square root 3 and negative 1. So we get 3. So square root 3 times square root 3 is 3. And then square root 3 times minus 1 is negative square root 3. And then 1 times square root 3 is positive square root 3. And then 1 times negative 1 is minus 1. Now we can simplify the numerator. Now in the numerator it's a square, so we can rationalize it. So it's basically the same thing we could have done in the numerator. So we get 3 minus square root of 3 minus square root of 3 plus 1. Basically we expand the square. And in the denominator, the negative square root 3, positive square root 3 cancel each other out, and 3 minus 1 becomes 2. So we get 3 plus 1, which is 4, and then minus square root 3 minus square root 3 becomes 2 square root 3 over 2. Now we can divide both terms by 2, so we get 2 minus square root of 3. So let me show you the step here, so we can break it up into two fractions. Right, and then we get this step. So this should be the final answer for the exact value of tan pi over 12. So I hope you find this video useful. Please share it, like it, and subscribe to my channel. Thank you very much and have a nice day. Bye.